All right, class, welcome. Today, we're going to pull back the curtain on a piece of technology we all use every single day, but maybe don't fully understand: Wi-Fi. You know, it really does feel like magic, doesn't it? Getting the internet right out of thin air. But how does it actually work? Well, let's break down the science behind the so-called magic.
Okay, so I have a really simple question to start us off. This whole Wi-Fi thing, how does it work without any wires? It seriously seems like magic to me.
That is an excellent question. And you know what? Before we get to the how, let's first understand the what. If we strip away all the marketing and the fancy names, what is Wi-Fi at its very core?
In the simplest terms, Wi-Fi is just a way to send and receive information using radio waves. It's exactly the same principle as your car radio or even your cell phone. Its official, very technical name is 802.11 networking, which was basically the code name for the group of engineers who developed it. But let's be honest, Wi-Fi is just a lot easier and cooler to say, right? So, if it's all just a game of radio waves, then how does this magic actually happen? How does something like a YouTube video or an email get turned into an invisible signal that just flies across the room? What you're seeing here really shows that Wi-Fi is a constant two-way conversation. Think about your laptop. It takes the ones and zeros of your request and converts them into a radio signal. It sends that. The router acts like a translator. It decodes the signal and then sends that information out to the internet through a wired connection. Then the whole process happens in reverse. The router gets information from the internet, turns it back into a radio signal, and beams it to your laptop. And all of this is happening thousands of times every single second.
Okay, so we know it's a two-way radio conversation. But then why are some Wi-Fi connections so incredibly fast and others so painfully slow? Well, the answer is hidden in the specific frequency of those radio waves, which creates this constant trade-off between speed and range.
Yeah, about that. I always see 2.4 gigahertz and 5 gigahertz written on routers. What's the actual difference between them? And more importantly, which one is better for us?
Think of it like this. The 2.4 gigahertz band is like a single-lane country road. It can go a really long way, and it's great at getting around obstacles, but it gets congested very easily, not just from other Wi-Fi devices, but from things like microwave ovens and cordless phones. Now, on the other hand, the 5 gigahertz band is like a modern, multi-lane expressway. It can handle a ton of traffic at very high speeds with almost no interference. The only catch? It's a much shorter road, and it doesn't like going through tunnels, or, in this case, walls. This really shows the biggest strength of that 2.4 gigahertz band. Its longer waves carry the signal much farther and can push through solid objects like walls more easily. So if your device is far away from the router, like in another room or on a different floor, this is probably going to be your best bet. By comparison, the 5 gigahertz signal is more like a sprinter. It has a much shorter range under ideal conditions, and its power drops off pretty quickly when it has to go through walls and doors. But, and this is a big but, if you're near the router, in the same room, 5 gigahertz will always give you a faster, more stable connection. It's perfect for things like streaming 4K video or online gaming.
Now, just like our phones have evolved from simple calling machines and computers, Wi-Fi technology has also gone through massive upgrades over the years. We call these Wi-Fi standards, or you could say, generations. This timeline really tells the whole story. It started back in 1999 with a standard that would feel incredibly slow by today's measures. Then came huge leaps like the N standard in 2009, which started using both frequency bands. AC came in 2014, also known as gigabit Wi-Fi, and more recently, Wi-Fi 6 and now Wi-Fi 7 have completely changed the game, focusing not just on top speed, but on efficiently handling dozens of devices all at once. This table just highlights the incredible jump in performance. We've gone from a maximum speed of 11 megabits per second with the first popular standard to over 9.2 times gigabits per second with Wi-Fi 6. That's an improvement of more than 800 times. You can also see how newer standards like Wi-Fi 6 use multiple frequency bands to optimize the connection for every single device in your home. So that was a lot of technical detail, frequencies, standards, gigabits. But what does all of this actually mean for you, someone who just wants a stable connection for a work call or to stream a movie? Why is any of that? Okay, so let me see if I got this right. If my internet feels slow and I'm near the router, I should connect to the 5 gigahertz network. If the signal is weak in another room, then 2.4 gigahertz is pretty much my only choice. And if the internet slows to a crawl the second everyone in the house is online,
It means my old router can't handle the traffic, and a new Wi-Fi 6 or Wi-Fi 7 router would solve that problem.
Exactly. You've got it. And that's where we'll end today's class. We've seen how Wi-Fi has grown from a simple convenience into the invisible foundation of our modern lives. The newest standard, Wi-Fi 7, promises even more speed and capacity. So the final question for you is this. As this technology becomes even more powerful and seamless,